For our last lesson in this part of the unit, we're going to work on translating our equation. So what that basically means is if we were to take our kind of standard equation, we call it our parent function, y equals x squared. So nothing's being added or subtracted, nothing's being multiplied to x, it's just plain old x squared. That would look like a nice, simple quadratic equation, or parabola. Its vertex is right there at the origin. It's perfectly balanced around the y-axis. It's not stretched up. It's not wider. That's our standard function. Okay? So as we've been adding and subtracting and multiplying by things, as we're adding in additional things into our equation, it causes that graph to move around. So today we want to focus specifically on how do I make it move around? What different parts of the equation can affect where it's going to show up? So for today's lesson, everything is based around vertex form. So y is equal to a times x minus h squared plus k. So we're really looking at that a, that h, and that k, and what effect do they have on the overall graph? Do they move the graph? Do they change its size? Do they change its orientation? Okay, what effect does it have overall? So in our notes, it's got some of it spelled out, and then we're going to talk about what it actually means. So if our k value, so that's that number at the end of the problem, is a positive, so it's greater than 0, it's going to translate it that many units up. So that means if my k is a positive, my graph is going to slide up that many units. If my k value is a negative number, so it's less than 0, it's going to get translated that many units down. So if k is a negative, my graph is going to head that many units down. Okay? Then I look at my h value. So that's that h on the inside. Remember, h is being subtracted from k. If that h value is greater than 0, if h is a positive number, it's going to move that many units to the right. So if h is a positive, it's going to move to the right. If h is a negative number, it's going to get moved that many units to the left. So if h is a negative, it's going to move that many spots to the left. So my k value, what gets added on at the end of the problem, causes it to shift up and down. My h value is what makes it move left and right. All right. So there's two examples here for you, so you can kind of see what they mean. Here, they put in a 3. Remember, we wanted a minus, so this is really a minus 3. So our h is negative 3, so it slid it over 3 spots to the left. Here, they added 4, so our k was 4. That caused the graph to slide up 4 spots. So let's take a look at that in each of these cases. So everything is focused around our parent function. Remember, when it says f of x, that really means the same thing as y equals. Okay? So it's just saying the function in terms of x, or it can also just say y equals. That means the same thing. So take a look at the first one. Notice there's something added on after the squared term. That means it's my k value. I have a k of 1, so it's going to go 1 unit up. Here, I have inside the parentheses, it's before it's squared. Well, that makes it my h value. I have an h of 6. That means it's going to move 6 units right. My h value slides it left and right. My k slides it up and down. So here, I've got a 1. But remember, we always want that subtracting. So this was really subtracting a negative 1. So I have an h of negative 1. So it's going to be 1 unit left, because if h is a negative, it's going to move to the left. Here, I've got my x squared plus 20. I'm going to rearrange it so it kind of fits my form. So that means my k is 20, so it's 20 units up. For the next one, I'm going to do a little bit of rewriting, because it's in the parentheses, so that's going to be my h value. But I'm going to rearrange it as x plus negative 2 squared. And if you think about it, plus a negative 2 is the same thing as x minus 2 squared. So my h value is 2, so it's going to be 2 units to the right in the positive direction. Here I've got a negative 1/2. I'm going to move it behind my x squared. So it's being added on after the squared term, so that's my k value. So my k means it's going to go 1/2 unit down, because it's a negative. Next one, x squared plus 8/9. So it's after the squared term, so that's my k, 8/9. So it's going to go 8/9 units up. Here, I'm subtracting 0.3. So it's after the k term, or after the squared, so that's my k, negative 0.3. So negative 0.3 units down, because it's headed down. For this next one, there was a typo there, so I want to get rid of that 4. So I have x plus 4 squared. So this is going to be an h value. Well, this was really minus a negative 4. My h is a negative 4, so it's 4 units left. Okay? So my k value slides it up and down. My h value slides me left and right. All right, so next part. And this is actually something we talked about earlier in the unit. They're just going to phrase it slightly differently. If our a value, so that number out front, in front of the x, is greater than 1, it's going to get stretched vertically, meaning they're kind of taking the edges of it and yanking it up, so it's kind of getting stretched up, so it's not going to be quite as wide anymore. So this is, we called it narrower before. Okay? If a is in between 0 and 1, so a decimal or a fraction, it's going to get compressed vertically, which is another way of saying it's going to get wider. Because think of like a kickball in gym. If you sit on it, you're squishing it, you're compressing it down, it's going to get wider as it squeezes out to the side. So this was our original function. That was our parent function, y equals x squared. When we stretched it, it became this one. Okay? It got pulled up, so it wasn't quite as wide anymore. When it got compressed, multiplying by a decimal, here's where it got wider. Okay? It got pushed out to the side because it wasn't climbing as quickly. And then our last part, if it's the opposite, so think of it as a is a negative number, it gets flipped across the x-axis. So it just gets flipped to the bottom. So when a is positive, it's pointing up. When a is negative, it gets flipped upside down. Okay? And then they've got a couple of examples there for you at the bottom, kind of walk you through them. But we're going to try and put it into use here on these next couple. So let's do just a couple of these together to see if we got the right idea. So here, it's in front of the x squared. That means it's my a value. It's a negative, so it's going to be upside down. Or you could write it as opens down, however you want to phrase it. And then the 5 means it's going to be narrower, or you could say stretched vertically. Okay. Next one, there's two things going on. I've got the negative 1 as my a value, so that means it's going to open down. It's going to be upside down. And then my h value is a negative 1, so it's going to move left 1. So next one, I'm multiplying by a negative, so it's going to open down. I'm multiplying by a fraction, so it's going to be wider, or they call it compressed. And I'm subtracting 1 at the end. That's my k value. So that means it's down 1 unit. Okay. Next one, I'm multiplying by 3, so it's going to be narrower, or stretched, however you want to phrase it. And I'm subtracting 4, that's my k, so 4 units down. Here, I'm multiplying by a decimal. That's my a value. So this one's going to make it wider, or compressed, as they say in this lesson. And I'm subtracting a positive 9. That's my h value. So it's going to be 9 units right. Okay. All right, last one. So I've got an a, an h, and a k value to factor in. So my a value means it's going to be narrower, because I'm multiplying by something greater than 1. My h value, well, this was minus a negative 1, so 1 unit left. And my k value is a negative 4, so 4 units down. All right, hopefully you got a good handle on that, and then you're going to practice a little bit in your homework.